This video, we're starting Chapter 10, which is all about intelligence and psychological testing. So this is us getting started on the concept of psychometrics. And I think we've mentioned the term before, but just in case, psychometrics is just looking at the metrics or the measurements and the data that you can collect from a bunch of different standardized psychological tests. So intelligence is a great example of something you could study with psychometrics, but we can also look at personality, which is coming up, and other topics like that. So one of the core ideas is having standardized tests where we can collect a lot of data, and then people can start looking at trends in that data or what kinds of questions we should or should not be asking in order to get at the things that we are interested in, and how to break down all of those different components into something useful, and all sorts of things like that. It's actually a really interesting field that's very up and coming as we try and collect as much data as possible and gain a better understanding of a whole bunch of different facets of sort of humans and their behavior. But like I said, this is just us dabbling into the waters, starting with just intelligence, and then in later chapters we'll add other types of things that can be studied using fairly similar methods. But our outline for the rest of this chapter, we're going to start off with a discussion about what intelligence is, including a couple of little tidbits and neat facts or neat concepts. We'll get into a little bit of the history and some of the theories, especially early theories, and how they get into sort of more modern approaches. We'll talk about some of the different measures of intelligence and some of the methods that can be used, including some discussions of some specific intelligence tests, as well as other types of tests that relate. We'll then look at how people decide to break down the different components of intelligence, as well as at the end, we get into some of the findings on variation in intelligence. So when we have all of this psychometric data, what are some of the big patterns that we see? And we'll also continually throughout this chapter be adding those caveats, that moment of critical thinking where we can absolutely look at a score or a difference between two groups, but we have to think about what that difference actually means, because a lot of this research is going to be correlational. Almost all of it will be correlational, depending on what it is we're discussing. But we'll get into all of that. The first step is, if we're going to talk about intelligence, well, what is intelligence? How do you actually define intelligence? And so when we think of the concept of intelligence, we typically think about things like, being smart or scholarly or well-informed or knowledgeable, possibly. And that kind of ties in with the original definition, which is the ability to discern true or important information from false or unimportant information. Can you tell what's right or correct and what is incorrect? Can you find useful things and ignore unuseful things? Basically, how do you process different kinds of information? Now, of course, this isn't necessarily how we would talk about intelligence today. And this is one of those fields that's evolved and changed fairly dramatically over time, where you might be thinking of nowadays, we have discussions about other types of intelligence. So not just book smarts, but maybe some practical knowledge. We also can look at things like emotional intelligence has been a big key topic in recent years that you might have heard of. And so we keep adding on to what may or may not be included in our understanding of intelligence. Hence why we'll talk about a whole bunch of different theories about how we should break intelligence down and what should even count when we're considering intelligence. So what's another way that we could define this that might be a little bit more in line with what we'll talk about today? Maybe we can view intelligence as the ability to solve novel problems and to learn from experience. So we're looking at problem solving, kind of a carryover from the last chapter, but solving new problems. And you can do that with experience or with some creative or fluid thinking, but also that learning from experience of, can you absorb information as you encounter it? And then once you've absorbed it, can you use it in the future? So this could contain things like pattern recognition, So can you observe patterns? Can you predict missing pieces from those patterns? Could you extend something that's occurred in the past into some theoretical future? Could also look at analogous transfer. And this is what happens when you find a similar situation, possibly in your past. So I've encountered a fairly similar problem, or I've encountered fairly similar knowledge, and I want to carry it forward to apply to something analogous or very similar in nature presently. And that involves not just can you actually take the information, you've remembered it, and now you can use it in an appropriate way, but also the fact that you recognize that there's a parallel between the prior and current situation. So a whole bunch of different aspects from such an apparently simple term. And then we can get into reasoning. So logic, can you rationalize your way through a solution? And this could be involved in, say, collecting the information that you need to make these logical decisions and then to sort of see them through. And you've probably picked up on the fact that from all of these discussions, a lot of what we're stressing into is this idea of behavioral flexibility, the ability to adapt and change and use different sort of approaches, apply knowledge in novel ways, and things like that. So a whole bunch of different aspects. And like I said, a lot of this is very consistent with the topics we discussed at the end of the last chapter, looking at problem solving and how we work with information. So we're building off of that into our new concept today. And so before we get too much into our history, which I'm sure everyone is very excited about, I have two concepts that I just wanted to mention briefly. The first being the self-enhancement bias. And this is people's, in general, people tend to do this tendency to judge your own performance as better than average without any evidence of actually having some special expertise or training or skill in that particular area of performance. This is not exclusive to intelligence. This is just a pattern with human behavior in general. But there have been a couple of interesting studies where they will go out and survey a whole bunch of people, and they'll ask, are you of average intelligence, above average intelligence, or below average intelligence? And about 70% of people will say that they are above average in intelligence, which is definitely not how averages work. And so you have to look at, well, what creates this bias here in their response? And there's a whole bunch of different factors that can play a role. Some of it might just be that people have a bias to view ourselves very positively. And intelligence is one of those things where people think of it in terms of, say, smart and dumb. And they want to be the one that has positive connotations. And so because they want those positive connotations, they can sort of inflate their intelligence upwards to help support that feeling good about yourself. In later chapters, we'll talk about a bunch of different ways that people tend to do this, but we artificially think higher of ourselves. This could also be the fact that maybe people have different definitions of intelligence, as we've discussed. But it could also just be that if you are below average intelligence, you might not have a grasp on the, say, detriments or the hindrance in your abilities. So you might not realize that you are on the lower end of the spectrum simply because you maybe don't understand how averages work. There's a whole bunch of different ways that people can explain this, and in previous classes I've had people add to the discussion about this, where there could be a lot of things affecting this self-enhancement bias. But it is a pattern that we see very consistently, so I figured we'd mention it here. Another of those interesting topics to discuss is the Flynn effect. And you might notice this is out of place in your slides, but that is actually because I accidentally dragged and dropped it to the wrong place. So I put it here because it doesn't really fit nicely anywhere else. But the Flynn effect is this idea that when we look at the data, once we had designed all of our intelligence tests, once we get to that point of having an IQ, which we'll talk about the history of that later, we look at those IQ scores across countries and across time, and even globally, we see this pattern that over time, the average IQ is creeping upwards. And so what's happening is that we see that over a couple of decades, we start seeing that this intelligence quotient goes from the average of 100, which is what these studies are designed to have. I think we've mentioned it before, but when they choose the questions for an IQ test, when they look at how they score those tests, an average person is supposed to score 100, so they adjust the metrics to make that happen. And then we get a nice normal distribution so that we have sort of this prediction of where people should fall on average within a population. But that average of 100 has crept upwards. So after a couple of decades, instead of a 100 average, it's 105, 107. And it is a fairly slow creep, so we're looking on the scale of decades, but we are still seeing this upward creep. And so our IQs seem to be increasing over time. And some of the people that propose different theories of intelligence that we'll talk about shortly would look at that pattern of increase in intelligence and say, aha, evolution is acting and making us smarter because those individuals who are smarter are more successful, and therefore they pass their genes along more, and therefore future populations have more intelligent genes and are therefore smarter people. But we should note, and have possibly figured it out by now from other discussions, that evolution occurs a lot slower than that. Evolution as a process is going to occur over hundreds of thousands of years. And so even if we looked at the difference between, say, our hunting and gathering ancestors, 10 or 20,000 years ago, I think is the scale. Even from then until now, it's a very slow process. We wouldn't see a huge difference in the machinery, the biology behind the scenes that affects intelligence. And so if it's not a biological influence, then what the heck else is going on? Like, what could it be? And there are tons and tons of theories on this, but the most common factors that tend to be discussed are just changes in our environment. So things like the fact that globally, as our understanding of human biology and medicine has changed, we're seeing an increase in nutrition and medical care and things like that. So we know that people need certain nutrients, and as those are made available, at least in some areas or most areas, hopefully, we start seeing that, hey, development is able to progress more consistently. So we're not worried about having deficits in different nutrients negatively affecting your brain growth and development. Also, improved medical care does similar things, make sure that we grow up healthy without any detriments from environmental factors like disease. So that might help a lot with us seeing that we have better cognitive functioning because we're not suffering from other things. We're also across the board seeing improvements in education. As we're understanding how people learn, we are then improving the methods that we use to teach people. And a lot of tests, especially the ones that would be used for the Flynn effect, where we get a single IQ number reported at the end, they tend to test in ways that are consistent with the patterns of thought that are encouraged through education within a particular country. Meaning that if you are taught better, you are now thinking the way that they want you to think, the way that you've been taught to think, and then these IQ tests are actually testing your performance by thinking that way. And we'll actually see that this ends up being more aligned with, rather than just an intelligence test, kind of like an achievement test, because you're measuring how much you have achieved in terms of absorbing the knowledge that was presented in school. But that's, again, something we'll come up to again later. And then the last one is kind of a really cool point. And this says that as technology has advanced and as we have these more complicated and interconnected lives, that might actually be encouraging us to develop cognitive flexibility. And so basically, if you look at it, instead of just interacting with the people in your own community, and maybe you see some stuff on TV and that's your insight to the outside world, nowadays, sitting on your computer, listening to this lecture, you have access to going on and chatting with people around the world. You can play video games that involve really complex problem-solving abilities, and even things like improving your hand-eye coordination, which we'll see can tie to certain aspects of intelligence later. And having an environment that helps facilitate acquiring some of these skills, we can absolutely consider that to be an enriching environment. It's encouraging us to develop these skills that would then correlate with intelligence, our IQ scores, at least for these tests. So that could absolutely play a role here as well. And so the point of this is that if we just looked at the numbers, if we just looked at over time intelligence is rising, we might conclude that people are just smarter overall and maybe erroneously conclude that it's biology or something like that. But there are all of these other factors that are running in the background that we should also be aware of. And that kind of thinking is going to be really important for this chapter, as well as really for the rest of the course. It's also already been important in our previous chapter, but this is a pattern that we're going to get used to, and hopefully you'll carry it off into other classes as well. We're being critical of the information presented to us, which is one of those qualities of being a good scientist or being a good consumer of scientific literature. But before I run off too far on that tangent, we're going to get into some of our history. And as per usual, I will stress that this is a very, very brief, very sort of truncated, isolated history of intelligence. We're only going to hit a couple of famous figures, but there are many, many more people that have been involved in this process in the background. But we have our standard bias, especially towards European and North American sources, simply because that's North American texts for you. But with that disclaimer out of the way, if we get into some of our early philosophies of intelligence, you should be unsurprised that we get into this concept of, or we get all the way back to our Greek philosophers. So Aristotle had a lot of thoughts on a lot of different things, and intelligence, or as he called it, wisdom, is definitely one of these things. And so Aristotle was focused in on two distinctions, two categories of behavioral flexibility, or this ability to apply your knowledge. And so he talked about practical wisdom and theoretical wisdom. And you can actually think of this kind of like the modern framing of street smart versus book smart, where practical wisdom is, can you take the information that you have and apply it in a real world situation? Can you make use of or sort of act on a bunch of these concepts, this knowledge that you have available to you? And can you apply it across multiple real life scenarios? This could include your reasoning to be able to figure out what is the best way to use this knowledge. Whereas for theoretical wisdom, this is more like scientific reasoning and theory. Can you think about how this could theoretically work? So this is just understanding some objective truth in his ideas, saying that I understand how these should be related to one another. I can go through these logic problems and things like that. And this can end up influencing your beliefs and how you sort of frame things in the real world, but it keeps it to that sort of theoretical side of things. And you can be very good with theory and very poor with practical wisdom, or you could be the opposite, or you could be high in both or low in both. But the idea was there are two types, two categories, and your performance in one might not be related to your performance in the other. Of course, back then they didn't necessarily have any way to quantify this. This was actually Aristotle applying his theoretical wisdom about how we should frame intelligence. So kind of a neat start here. Now, rather than continuing in a chronological order, I had decided to sort of take a little bit of a stop here and talk about a much more modern perspective. And this is Williams, who in the 1990s, since we're talking about Greek previous to this, Greek philosophers, Williams ended up doing a breakdown, a deep dive into a whole bunch of ways that people have talked about intelligence, ways that people have looked at intelligence, and ended up kind of framing things too far off from what we saw with Aristotle. So where Aristotle was looking at that behavioral flexibility and our ability to sort of adapt to either real world scenarios with that practical component, or to think in more abstract terms with the theoretical component, Williams really leaned into this idea that, yeah, intelligence is something that should be allowing us to adapt to changes and learn from our experiences. So instead of focusing on, do we apply it in a practical way or a theoretical way, this is saying that that flexibility behind the scenes is what might be really important. And so here we have a couple of terms that are important to understand. That adaptation component is looking at, from an evolutionary point of view, if we talk about adaptations, we could be talking about things that are then beneficial or help us with surviving and thriving in the long run. But like we said before, I'm stressing that from where humans became humans to where we are now, there's not a whole lot of evolutionary change that could have occurred in such a short time on that scale. So adaptations here would probably be more about adapting in the short term, a more societal use of the term adapt, where it's mainly just, can you change your behavior? Can you be flexible in your behavior? And as per usual, that learning component is just talking about sort of taking information and experience from your past, storing it, and being able to apply it in the future. So this is focusing on that ability to gain knowledge through learning and then apply it in some way that helps you solve problems in order to adapt and survive in your environment that you're in presently. And this can tie into some of our ideas where we look at this adaptation, this ability to survive and thrive, can be really, really important. Which is my way to sort of bridge the gap to our next individual, hopping back in time. So now that we've gone from our Greek ideas to a little bit more of a modern framework, but also acknowledging that there is potentially that genetic or biological component, we get into Sir Francis Galton. And whenever I mention Galton, I always give that sort of caveat that he is very much a product of his time. He had a lot of ideas and he contributed to a lot of different fields. So not just looking at intelligence testing and how we should quantify intelligence, but he's actually the person who proposed the concept of correlation within statistics. He talks about the weird phenomenon of regression towards the mean, where data tends to get sort of less extreme over time if you keep measuring similar things. He also is the person who coined the phrase nature versus nurture. And he got into a lot of our different discussions of what is now considered psychometrics. He's the person who devised a method to use fingerprints and classify them so that you could use them in crime analysis. And so all sorts of different things that he was involved in. But in addition to all of those contributions and things that are still very much in use today, including this idea of testing for intelligence, he was also a very problematic figure. And so he looked at, or I guess starting with his influences, Darwin's theory of evolution was one of his sort of core tenets. And problematically, he was a proponent of social Darwinism. And so social Darwinism is the concept that those who are at the top of society, the aristocracy, the elite of society, they are at the top because their genetics, their what we would call, or I guess even what we call now genetics. For him, it was their biology, their sort of everything that makes them who they are internally, any heritable components. That is what makes them superior. So he viewed it as the rich and the powerful are rich and powerful and deserve to be rich and powerful because they are superior to others all the way down to their biology. and their success and their intelligence is something that is inherited. So rich, powerful, very business smart white men would have then sons who grew up to be rich and powerful and business smart white men. And in this case, he used that as an argument that mental ability is inherited. And he also focused on the fact that the lower classes at the time, people who were working in factories, doing menial labor, sort of living moment to moment, those individuals were at the bottom of society because they were somehow inferior to those at the top. And say a lowly factory worker would often have children who would also be lowly factory workers. And this was all kept in place by this inherited quality where some people are better than others. So that sentiment on its own is one of the main reasons why he is such a controversial figure. But also he took it further. In addition to all of the other things that he pioneered and proposed, he's also the person who proposed eugenics, implying that there should be controlled breeding, where the rich should not end up marrying and having children across class lines because you wouldn't want to dilute the higher intelligence of those in an upper class. So yeah, it keeps getting worse. And when we get into it, he started making a bunch of measures, and he was really focused actually on the perception side of things. He thought that a lot of our intelligence came from how we see our environment and how we interpret the information that we're taking in from our environment. So to be smart, you have to be able to observe and predict patterns that you've observed in behaviors and items and things like that. So he focused on these perceptions. And so he measured and quantified a bunch of these perceptual abilities. And he used the fact that the highly educated upper classes tended to perform better than the not educated lower classes. And he said, well, the scores tell us for sure that there are very distinct differences and these people are better than those people, which we would now call scientific racism, because he designed tests that the rich and educated would succeed on and used the data that he got from that to sort of feed into this idea that the rich are therefore superior. So it was all he designed tests to support the ideas that he had. And that's why in a lot of cases, some people don't even mention Galton as a figure to talk about. But we're acknowledging where it came from and the faulty logic that led him to start doing this. But we're taking from this, we do know now that yes, there is a genetic component to mental ability or to intelligence, but it's not as deterministic as he was convinced it was. We also can take his idea of measuring and quantifying different things that we think are related to intelligence, because that's the start of this idea of intelligence testing. So being able to quantify things and make comparisons between individuals can be useful, just not when employed in a really harmful way. So yeah, this is our starting point, but we move on from here to some other figures. Not necessarily less controversial figures, though. So our two next figures are Binet and Simon, which they're technically French, so it should be Binet and Simon, but my French accent is absolutely terrible, so I will just bastardize it to the English version of it. But at least you know that it's French if you hear someone else say them properly. But these individuals, they were in France, and they were tasked by the government, or at least involved in the government's idea of separating sort of gifted from underperforming children. So the government was looking at the fact that they wanted everyone, all the children within France, to be going to school. They mandated that all children had to be in a school for a certain amount of time. And the issue there being that some people had already been in school or had been receiving, say, education and tutoring at home, especially from wealthy homes. But when they found they put all the children together, some children were overperforming and others were very much underperforming, having having had no experience with formal education prior. And so the government wanted to find a way to divide those up. And specifically, they wanted to put those who underperformed in a special program that would either have them institutionalized and removed from society where they wouldn't be a drain on resources, or to put into alternative education programs that would basically set them up to go into working menial jobs. So prepping them to work in a factory for the rest of their lives. And while Binet and Simon didn't necessarily disagree with that division, they disagreed with the method that was originally proposed. And the original method was using these very subjective evaluations from the teachers who were interacting with these children and the children's parents, and maybe psychiatrists if they thought to get them involved. But in this situation, this is very much influenced by those individuals. So one teacher's standards for high or low achieving could be very different from another. And this lack of standardization really, really bothered, especially Simon. And so he said, we should be designing some kind of standardized measure to make this determination between high and low achieving children. So this is where we get our first intelligence test, our first standardized test. And it was designed to quantify this mental ability in these children. And then they could use it to divide it into sort of continuing education versus do we send them for remedial programs. And something kind of neat here is we start seeing a little bit of an acknowledgement of the difference between aptitude and achievement. And I kind of hinted before that the concept of achievement is looking at how well you've absorbed information. So if we have an achievement test, that would be like a midterm exam. I'm looking to see how well you have absorbed the knowledge from this course and a little bit of how you can apply it. But if we wanted to get into aptitude, that's when you're looking at how much potential do you have to, say, learn and apply things in the future. So maybe some creative logic type questions on a test where maybe even you don't have to know the base information. I could maybe give you some base information and then ask you to logically solve a problem. I don't do that in case you immediately panicked, but ask you to solve a problem in a particular way. Those who have high aptitude would be able to be very flexible in absorbing the new knowledge and applying it, but we wouldn't be getting at what do you already know. It's about what do you have the potential to know. And that concept, that separation, ends up being more refined as we get into the future. But at the time, even acknowledging that there were slightly different types of questions that could be asked was really, really important. And so from this, I guess we should acknowledge first off that we had some useful assumptions developed in this point that ended up leading over to our first calculations of an actual IQ score. Because here we didn't necessarily quantify it the same way we do now. They had their own sort of scores and standards and cutoffs for the purpose it was being used for. But Binet, from this setup, came to two main assumptions. The first being that our mental abilities develop with age. So as we get older, we are able to think more complexly, we're able to solve more complicated problems. Basically, we get smarter as we get older. And I should stress, this is specifically applying to children. As soon as we get into adulthood, this sort of gradual, steady progression changes. But for children, mental abilities develop with age. And so we could look at a 10-year-old, and there is sort of a set of questions that a 10-year-old should be able to solve, and other questions that we would not expect them to be able to solve. And that's sort of the average performance for a 10-year-old. An 11-year-old would solve more of those problems and have fewer that they weren't capable of. But if we looked at a 9-year-old, they couldn't solve as many. So different ages should have different mental abilities. The second assumption is also important, and this is the fact that they said the rate that people gain these mental abilities is characteristic to that individual. meaning that if somebody performs better than their age should be expected to perform at a young age, so say at 5 years old, they are above average in their performance. If we looked at that same child again at 10 years old, we would expect them to still be above average. And when we look at them at 15, they'd still be above average. And so the prediction would be that sort of standard or that progression should be fairly consistent over time. So if you get one measure of a child's performance, it should be indicative of sort of where their scores would lie as they get older. And they could ask questions that would kind of allow this to occur. So that's a really important starting point because it allows us to get here to William Stern, who developed the concept of our mental age and also used that idea of mental age versus our physical age and what we would anticipate someone could do at their physical age, and we can compare the two. So this is kind of how we think of our normal IQ test, or I guess not IQ tests. This is how we would conceptualize our current IQ scores. So a higher IQ score means more intelligent, and a lower IQ score means less intelligent. However, modern IQs are not necessarily quotients anymore. They're not calculated the same way. It's not a ratio any longer. So this is where it started. And the name stuck, but the technique changed, just to make that clarification, because it gets kind of weird to be talking about IQs in a bunch of different ways, but depending on the person you're talking about, they're very different concepts. The standard thing in psychology to call many things the same name or to call the same thing many names, we do all of it. But that caveat out of the way, Stern said, okay, we'll have our ratio IQ. So this would be, how does this individual compare to what we would anticipate for somebody of this particular physical age? So you divide a person's mental age by their physical age and multiply by 100. And so we would say that if you are, so your mental age matches your physical age, then you get a score of 1. 1 times 100 is 100. So that's where we get that average score of 100 that's carried forward to today. If your mental age is higher than your physical age, if you are performing better than would be anticipated for your age, so maybe we have a 10-year-old who can answer questions like an 11-year-old, now we would take 11 divided by 10 and then multiply it by 100. And so now we would have an IQ score of 110. And so they are above average, their score is higher than 100. If we had a child who scored below what we would anticipate for their physical age, so their mental age, they answer questions the way that a 9-year-old would. 9 divided by 10 times 100 is now 90. So they are below average in their scores. Now, as per usual, whenever we talk about things that we have equations to calculate out, I always stress that I don't ask you to calculate things. I would more ask that you understand the concept, where if a person's mental age is higher than their physical age, they are above average. If their mental age is below their physical age, they are below average. And if they match, they are average. They're performing as expected. That's the extent of what you need to know. You don't need to do the math. I just figured for some people, having actual numbers can help. And so that is our ratio IQ. That's saying, how does this person compare to others of their age based on our standardized questions? You will on occasion see something called a deviation IQ, and this is slightly different. And this is when we would take a person's test score and we would divide it by the average test score of people in that same age group for the group that we are investigating. So this is instead of against sort of our larger standardized scale, this is more of a smaller scale. and times it by 100 once again. And so we're just looking at sort of smaller differences on the scale of a group rather than looking at an individual as compared to the standard for the test. I don't really talk about this deviation IQ beyond this slide and acknowledging that it exists. I would much more rather ask you questions about the ratio IQ and what it means when we get those mental versus physical age differences. But like I said, acknowledging that it exists in case you encounter it in the future.